Professor Bialis here. In this video we're going to talk about section 2.6, which is talking about percents. Now we're going to start with something simple just to get a translation part of it down, and then we're going to look at actual applications of percents, which are very, very applicable to everyday life. Going to the store, buying something on sale, buying something and selling it for a markup, investing in stocks where you want to get a certain percentage on your return, that kind of thing. So this is a very, very useful concept. We're going to just kind of lay the groundwork for the basics in this section. So let's start out. We're looking at section 2.6 and we're talking about percents. Okay. Now, when we look at the setup for percentage problems, there's two main setups that people typically use. The first one is percent over 100 equals is over of. Okay, this is the one that they typically start out when you first get introduced to the idea of percents. This is typically where we start. The problem with this is if you go into problems that utilize more than one percentage scenario or more than one percentage at a time, this cannot really be used very well. Okay, so another way that you can look at this is percent times whole equals part. This is the layout that I will be kind of pushing in this section. If it's a simple problem you want to go with this, go right ahead, but this is the setup that I'm going to ask that you guys kind of focus on. Now here's the thing we got to be careful with. A percent is simply a part out of 100 units. Okay, so instead of saying hundredths, we can say percent. Okay, now if we have, let's say, 36%, and you're using this setup, you plug in 36 because it's already 36 hundredths. But if we're using this setup, we always have to write it in decimal form. So that percentage must be in decimal form. Okay, so if I say 36%, I would say 0.36. If I have 82%, 0.82. Okay, so make sure you're aware of that when you're plugging that in or taking it out. If you solve that equation for a percentage, it will be given to you in a percentage or in a decimal form. So we would have to convert that decimal back over to get the percentage. Now, if you are used to this, then these two parts here, the whole and the part, can be brought back to the is and the of. Okay? The whole part of the problem is going to be the of part, and the part of it is going to be the is. Now, one thing I want to be very clear on is what that does is it creates a translation. You don't have to memorize this formula. Of, if you translate it into an algebraic or an arithmetic setting, of means multiply. Is means equals. Okay, so really this is a translation type problem. This isn't a, you got to just know the formula and plug it in. Translate the concept and you're going to be using this automatically. Okay, so let's look at a couple of very basic percentage type problems. This is practice 1 in the book. Okay, and it says 35 is what percent of 56? There's no application here. It's just how do these numbers interact with one another. So when we do this, translate it. Watch how I do this. I've got 35 is what percent? I don't know. I'm going to use that percentage symbol almost like a variable, but I use the percentage symbol so I remember that's what I'm finding. Of means multiply, and then we have a 56. That's it. I didn't have to reference this. I literally just translated. And then what I do is I divide by 56, and when I do that division, I should be getting a 0.625, and then I move that back to get a 62.5%. That's what I mean by when it comes out of that formula, this is a decimal form. To get it in a percentage form, I'm moving that back 2 spots. And it's as simple as that. Let's look at one more. Practice 2 says 198 is 55% of what number? Okay, so again, translate. 198 is, means equals. 55% is a 0.55. Of means multiply. And what number? I don't know. And now a very simple equation is left. I divide by 0.55. And 198 divided by 0.55 gives you 360. Okay? And that's it. Again, basic translation when you're dealing with scenarios like this. Now let's go into an application that is, something that we would see in our everyday life. So I'm going to skip to practice 4, and that is found on page 131 in the textbook. And it reads, a used treadmill originally purchased for $480 was sold at a garage sale at a discount of 85% of the original price. What were the discount and the new price? Okay, this is something we've all encountered. We're buying something on sale. In this case, it was a garage sale, but you can buy it at a store and they have a 30% off sale type of a deal. Okay, so as always, read through once to get an idea of what they're talking about and then start pulling the information out. Again, a used treadmill originally purchased for $480 was sold at a garage sale at a discount of 85% of the original price. What were the discount and the new price? So, when we're dealing with something that is on sale or you're marking it up, there are going to be some key components we always deal with. And that's going to be an original price, a new price, and in this case, there's a discount. Now, discounts, think of going in a store. You may get something on sale that says $10 off. Or you may go in a store and they say 20% off. Okay? There are 2 types of discounts. There's a discount in terms of percent, and there's a discount in terms of dollar amount. Okay? These are the key components that we're going to be working with. Let's pull those out of all that wordiness. So it says, used treadmill originally purchased for $480. There's my original price. Okay? Was sold at a garage sale at a discount of 85%. So the percentage discount is 85 of the original price. What was the discount and the new price? Okay? So, we are trying to find both of these things. The first thing you would find in this case would be the discount itself, the dollar amount of the discount. So if we're discounting 85%, we are cutting out 85% of the original. Notice I use that word of. Of means to multiply. So I am going to find the discount by taking 0.85, since it was 85%, times 480. I am saving 85% of 480. So when I do that multiplication, I get 408. So the dollar amount I'm saving is that's the discount, is $408. That's your discounted amount. How much is the new price then? Well, we simply take 480 and subtract 408. And all we're spending is $72. Be careful on something like that. Don't make the same mistake I did. Okay, so the amount we saved was 408. The amount we're spending is 72. Simple as that. Okay? All I did first was list the important information, stuff I knew and stuff I needed to find, and then I start seeing how they relate to one another. Okay? So now let's go to practice 5. That is found on page 132. Okay, practice 5 says, the tuition and fees cost of attending a public 2-year college rose from $1,900 in 1996 to $2,710 in 2011. Find the percent of increase. Round to the nearest tenth of a percent. Now, something I want you to always kind of gravitate toward is that phrase percent increase. It could also be percent decrease, but percent increase, percent decrease. That's the type of problem we're dealing with here. Percent increase, decrease. Okay, and the problem will say which one it is. They'll use that wording percent increase or percent decrease. Now, whenever you have that type of a problem, these are the things you're looking for. You're looking for an original, a new, and a difference. Those are the 3 main components that you're trying to identify within the problem. The original, the new, and then how did it change, okay? Because that change is really what the percentage is measuring, okay? So, again, we have the tuition and fees of a 2-year college went from $1,900 to $2,710. So we have an original of $1,900 and a new of $2,710. Okay? Now, when we take the difference, we subtract. The order that you subtract, it's not always going to be new minus original or original minus new. Always take the biggest minus the, or bigger minus the smaller. Okay, make it positive. So 2,710 minus 1,900 is 810. Okay, there's your difference. Now, the question that they're really asking us here is this. What percent of the original is the difference? That's the true question in these percent increase, percent decrease problems. Notice I'm not mentioning the new. The new was only used to find the difference, nothing more than that. Okay, so let's fill this in now. This wording that I created here is very similar to those first 2 examples where it's just translation. So what percent? I don't know. Of means multiply. The original, 1900, is means equals. The difference is 810. And now we solve. So we are going to divide and now we are going to figure that out. Now in this case, I would probably just go to a calculator, plug that in, see what you get. Now when you plug this into a calculator, what we're going to get is 810 divided by 1900. And I'm going to write out the whole calculator screen. I want you to do that as well as we get started here. We've got this. Now, in the problem it said, round to the nearest tenth of a percent. We're not a percentage yet. Don't round before you translate it to a percentage. Write the whole thing out, move it twice, and now you have a percent. That's what gets rounded. So I'm going to round to the nearest tenth. I have a 42.6%. And there we go. Okay, so again, don't round too early. I see a lot of people round here, and then they end up with a 40%. You just rounded to the nearest 10%. So make sure you get it in a percentage, then you round it at the very end. Okay? Whenever you see percent increase and decrease, this should automatically go on your paper. We need those three components, and this is the question that they're really asking. Write that down immediately once you see percent increase or percent decrease presented in a problem. Let's look at another one. Okay, practice 6 can be found on page 133. And it says, the fastest growing sector of digital theater screens is 3D. Find the number of digital 3D screens in the United States and Canada in 2012 if after a 7% increase, the number in 2013 was 15,782, round to the nearest whole. So again, in this case, it says percent increase. They have 7% increase. So right away, I should be writing original, new, difference, and then what percent of the original is the difference. Automatically put that on because that's all the stuff that we need to work through to get this problem solved. Okay? So let's now start pulling that information out. It says again, the fastest growing sector of digital theater screens is 3D. Okay, we're talking about theater screens, not a big deal. Then it says, find the number of digital 3D screens in the United States and Canada in 2012 if after a 7% increase. Now that 7% increase doesn't go here. It goes right here. The percentage is 0.07. Write it in decimal form so we can calculate with it. Okay? If after a 7% increase, the number in 2013 was 15,782. So after the increase, it was 15,782. So the new number is 15,782. Okay? What they're asking is, what number did we start with? What's my original? That is unknown. There's my x. Now, for the difference, remember we're subtracting, but do we go original minus new or new minus original? Remember, we always want to do it in the order that will leave it positive. If this was a percent increase, like they stated in the problem, that means that the new number should be bigger. So we are going to have the new number minus that smaller original number. It will make a difference if you put x minus 15,782. So make sure it's always bigger minus smaller. Now, given these three components that are algebraically represented, we can plug them in and make an equation. We already know the percentage is 7, so 0.07. Of my original, means multiplied by my original, is the difference. And we have that. I then add the x. Now 0.07 plus 1 is a 1.07x equals that. Now try to interpret what happens in these equations. It was a 7%, now it's a 1.07. Guys, think about that 1.07. If I move that back, that's 107%. We have 100% of what we started with plus 7 more percent. So these intermediate decimals here should be making sense as we go along. Okay? And then I divide by 1.07. And again, here I would probably be picking up that calculator and seeing what it says. Okay, so we've got 15,782 divided by 1.07, and we've got 14,749. Now, it said round to the nearest whole. What I'm getting here is that. Okay? Now, if they want to the nearest whole, we don't have to move any decimal place here because this isn't a percentage. This is just number of theater screens. So what I should be getting here is 14,700. I cut off here. This is going to round that up, so I have that right there. And there we go. Okay. So again, we don't always have to move decimals. It's only when we're dealing with the percentages themselves. Let's look at one more. This last one, last practice problem is practice 7. It's found on page 134. And this is what we call a mixture problem. Now, this mixture could be, liquid mixtures. It could be solid mixtures like with coffees or different kinds of nuts or candies or something like that. But it's still, we're mixing things together. Now, there's a lot of ways you can organize your data here. I like to draw boxes, and I'll explain in a second what I mean by that. But if you want to use a traditional table, by all means, again, if you have a way of doing this in the past that stuck with you and it works, by all means, go for it. Okay? So let's look at practice 7. Again, is on page 134. Okay, and it reads, Hamida Barash was responsible for refilling the eye wash stations in the chemistry lab. She needed 6 liters of 3% strength eye wash to refill the dispensers. The supply room only had 2% and 5% eye wash in stock. How much of each solution should she mix to produce the needed 3% strength eye wash? Okay, so for something like this, read through it once. Again, there was a lot of numbers there. I just want to know that we're mixing. That's the bottom line. Okay, since we're mixing, I like to draw, like I said, boxes. These boxes represent the jars of things that you're throwing together. So I'm mixing this with this to get this. Okay? Now, when we have something like this, there were 2 pieces of information. There were the quantity and then the strength. Okay? The quantity and strength. Now, when we think of labeling this, okay, we can think of it like a can of soda or something like that. Okay? If we have a can of pop that has the label of Coke or Pepsi, on the bottom, typically they have the 12 ounces or 20 ounces, depending on what size of the container it is. Okay, that's how we should be labeling this. So let's go back in there. It says, Hamida Barash was responsible for refilling the eye wash stations in the chemistry lab. Okay, that just gives us the setting. She needed 6 liters of 3% strength eye wash to refill the dispensers. So we know that at the end, we should have a 6% solution and 3 liters of it. Okay? Now, all she has in the lab, though, or in the stock room, is 2% and 5%. So, all we have to work with is a 2% and 5%. And I mix these up over here. This should be 3 and 6 liters. Okay, so 3% and 6 liters, yes. Okay, now I want to explain why I knew that I made a mistake there. Okay, when we're looking at these mixtures, the percentage we always get here should be somewhere in between this and this. There's no way that I'm going to be able to mix a 2% and a 5% and get something higher. Because if I have the 2% and the 5%, if I mix them, this gets strengthened, but this is going to get diluted and they're going to meet somewhere in the middle. So if you do make a mistake like I did, you should be able to catch it if you're paying attention to how those numbers interact. So again, 2%, 5%, mixing to 3%, that makes sense. And we need 6 liters at the end. Okay, so what they don't tell you is anything about the amounts here. Okay, so there are a couple ways to do it. When we get into systems later on, we can use a system. But here we have to deal with one variable. So this is how we're going to do it. I'm going to say I have some amount of 2%. I don't know how much, just a question mark. Okay. Now, if I need 6 liters at the end, let's think about it. If I need 6 liters in front of me, if 1 liter comes from here, 5 liters have to come from here to get the total of 6. If I need 6 and 2 liters come from here, 4 liters have to come from here. Now how am I getting this number? If it was 6, 1 from here, 6 minus 1 is 5. If I had 6, 2 from here, 6 minus 2 gives me the 4. I had 6 minus that first amount. So in this case, that's how I'm going to write that algebraically. I have a leftover situation. I have a total of 6. I already know I used x of it here. Leftover is going to be coming from this. Okay? So whenever you have a situation like this, where you have a variable here and a number there, it's the number minus x. Every single time. That's never going to change. X, number, number minus x. Okay? Now, what do we do with all that? What we're going to do is try to interpret what this means. 2% eyewash means if I have liquid in here, 2% of that liquid, remember that word of means multiply, 2% of that amount is going to actually be a washing solution. Everything else is going to be water or some diluting agent. So what we have is 0.02 times x. I multiply those two right here. Okay, that's all I do. 0.02 times x plus 0.05 times 6 minus x equals 0.03 times 6. Okay? That's all there is. Now I have to work that out and solve the equation. So when I do that, be careful with your decimals. I've got 0.02x plus 0.05 times 6. Be careful with this, because if I have 0.05 times 6, I get a 30 from 6 times 5. But there's 2 decimal places within this. Okay, so I've got 0.3 minus 0.05x equals 0.18. Okay? If it helps, since everything has 2 decimal places, throw that 0 on there. Doesn't hurt anything. Okay? Next, I've got 0.02 minus 0.05. I'm combining like terms. So I've got negative 0.03x plus 0.30 equals 0.18. I subtract 0.30. Oops, minus sign there. I've got a negative 0.12. I divide by negative 0.03. Two negatives make a positive, and then I get 4 as my result. Okay, now interpret your solution. X was the amount of the 2%. So I need to specify that. To get my 6 liters of 3%, I need to take 4 liters of 2%, and then how many liters of the 5%? That's where I get 6 minus x. 6 minus 4 is 2. And there we go. Okay? So notice there was a lot of decimal work here. Okay? You can clear decimals. However, me personally, I like working with the decimals in this type of situation because a lot of times when you do clear decimals, you get the numbers to be a lot bigger than they need to be. Okay, so, but if you prefer to clear the decimals, you can. I would still go to this step here, and then since they're all hundredths, you can multiply by 100 and then get rid of all those decimal places. That is a possibility. There's nothing wrong with that. That's just a preference thing. It's not a necessity. And that's pretty much it for section 2.6. Okay, so these are applications that are very, very useful in just day-to-day living. Take your time with them. If it's a sale kind of situation or a percent increase, decrease, or you're investing, try to put yourself in that situation. Really, really imagine yourself at a store buying that thing that you need and then it'll make it a lot easier to work through. Okay, take your take your time and be careful with your decimal places and just your basic calculation, and you'll do great. As always, if you have any questions, let me know. Work hard, and I'll see you next time.